Okay, so now let's talk a little bit about exercise 2.2. Exercise 2.2. So question, you want to prove basically number one, you want to prove that 3 sine inverse of x, 3 sine inverse of x is equal to sine inverse of 3x minus 4 times x cubed for sine inverse of 3x minus 4x cubed for x belonging to the interval negative 1 by 2 to 1 by 2. Okay. So to prove this, let's take a look at the properties of basically the properties that we had here. So these properties are basically, you have the reciprocal of x, and here you have x, and here you get sine inverse and cosecant inverse, cos inverse and secant inverse, tan inverse and cot inverse, and so on and so forth. Now these are about basically that, and so the next part is basically the sine of negative x is equal to, for example, negative sine x, tan of negative tan inverse of negative x is equal to negative tan inverse x. The cosecant inverse of negative x is equal to negative cosecant inverse x, and the same thing about cos inverse, secant inverse, and cot inverse. So these are not the kinds of things that we can use here. Here we have basically sine inverse plus cos inverse, tan inverse plus cot inverse, and cosecant inverse plus secant inverse, all equal to pi by 2 for these domains. And basically here we have tan inverse of x plus tan inverse of y, a couple of formulas for that. And then we have 2 times tan inverse is equal to sine inverse, 2 times tan inverse cos inverse, and 2 times tan inverse is equal to tan inverse of something. And so I think that there is no way to use these over here. What we can do is that I think we can use this, basically we can use this. You can see that this looks like some formula that we have proved before, meaning that 3 times x minus 4 times x cubed. That does look like something that we have done before, and that is for the sine of some angle which was 3 times something, 3, and that was basically part 3, I think. No. Part 4. No. No. Part 5. You see over here, sine of 3x is equal to 3 times sine x minus 4 times sine cube x, right? So I can use this formula here. I can say that basically, I know that sine of 3x is equal to 3 times sine x minus 4 times sine cube x, which means that if I set x is equal to sine and x is equal to sine theta, for example, let x be equal to sine theta, we have basically the RHS. The RHS is equal to sine inverse of 3x minus 4x cubed. And if x is equal to sine theta, then of course theta is going to be equal to sine inverse of sine inverse of x, right? So now I can write this as the sine inverse of 3 times basically sine theta, 3 times sine theta minus 4 times sine cube theta, and 3 times sine theta plus minus 4 times sine cube theta is equal to sine 3 theta, is equal to sine inverse of sine 3 theta, and that is equal to 3 theta, which is equal to 3 times sine inverse of x, 3 times sine inverse of x, and that is your your basically LHS. That is your LHS. And so basically, hence the identity is proved. Hence the identity is proved. Okay. Now the second part that we need, that we want to prove here is 3 times cos inverse x. 3 times cos inverse of x is equal to cos inverse of, we want to prove this one. Prove that 3 times cos inverse of x is equal to cos inverse of 4x cubed minus 3 times x. Now this 4x cubed minus 3 times x looks like cos of 3x to me. Cos of 3x, which is equal to again, we can take a look at the formulas, and the formulas tell me that cos of 3x is equal to 4 times cos cube x minus 3 times cos x. So if I set x is equal to, for example, cos of theta, I can somehow put the whole thing together, meaning that cos of 3x is equal to 4 times cos cube x minus 3 times cos x. So if I say that, let, for example, x be equal to cos of x, cos of theta, then basically theta is equal to cos inverse of x, right? Now the RHS is equal to the cos inverse of 4x cubed minus 3 times x, which is equal to the cos inverse of, now that is the cos inverse of basically 4 times x is equal to cos theta, so 4 times cos cube of theta minus 3 times cos theta, and 4 times cos cube theta minus 3 times cos theta is equal to cos 3 theta. So that is the same thing as the cos inverse of cos of 3 theta, and that is equal to 3 theta, which is equal to 3 times basically theta is cos inverse x, cos inverse of x, and that is basically equal to your LHS. That is equal to LHS. So that means that basically RHS is equal to LHS, and hence the identity is proved. Okay, so the next question that we have is tan inverse of 2/11. We want to prove that this is question number 3. We want to prove that tan inverse of 2/11 plus tan inverse of 7/24 is equal to tan inverse of 1/2. tan inverse of 1/2. So I think we can use the formula that we had, and the formula was I think I don't remember exactly this one. So we said that the tan inverse of x plus tan inverse of y is equal to basically tan inverse of x plus y over this. So let's see if we can use that formula. So basically we have the tan inverse of x plus the tan inverse of y is equal to the tan inverse of x plus y over 1 minus x times y. Of course that is for x times y is less than 1. Meaning that, for example, if you take your x as 2/11 and multiply it by 7/24, you will get 12. So that's 7 by 11 times 12 is equal to, well, that's some number less than 1, of course. So I suppose you can use the formula there. And so if I write, basically your LHS is equal to tan inverse of 2/11 plus the tan inverse of 7/24 is the same thing as, based on this formula, it's the same thing as the tan inverse of basically 2/11 plus 7/24 over 1 minus 2/11 times 7/24. So that is basically that. Now we need to calculate this, and I think it's going to be 1/2. So let's see what that is. So you know that 2/11 plus 7/24 is the same thing as 11 and 24 have nothing in common. So you have 11 times 24, and that is 24 times 2, 11 times 7, which is equal to basically 48 plus 77 by 11 times 24, and that is the same thing as what is 40 plus 7 is equal to 100. That is basically, let's calculate this. 48 plus 77 is equal to 15. So you have 11 and 12, 125. That's 125 by 11 times 24, right? Now the next part is 1 minus 2/11 times 7/24, which is equal to basically which is equal to 1 minus 14 over 11 by times 24, and that is the same thing as 11 times 24, and you have 11 times 24 minus 14, and that is that. So I can divide this by this one, and what I will get is that 125 by 11 times 24 divided by 11 times 24 minus 14 divided by 11 times 24. Cancel these two out, you will get 125 by 11 times 24 minus 14, which gives you, and what is 24 times 11? So that is 24, 0, 24, 4, 6, 264. 264, subtract 14 from it, you'll get 0, 5, 250. So that's 125 by 250, which is equal to 1 and 2, that's 1/2, right? So that is the same thing as the tan inverse of 1/2, which is equal to your basically to your RHS, and therefore you can say that basically the LHS is equal to RHS, and hence the property, or the identity, or let's call it the identity, is proved. So that was question number 3, which is okay, so that was question number 3. Now question number 4. There is another one of these that we can prove here. So we have 2 tan inverse of 1/2. So we have 2 times tan inverse of 1/2 plus tan inverse of 1/7. Tan inverse of 1/7 is equal to tan inverse of 31/17. 31/17. So how can we do this one? So here we had basically here I have a 2. That makes it not possible for me to 2 tan inverse of x is equal to tan inverse of this one. So what I can do is that I can use this thing over here, this formula, to write 2 tan inverse of x as tan inverse of x, and then once I have this in the form of tan inverse of x, then I can use this formula, number 5, part 1, in order to then put them together in order to write them as tan inverse of 31/17, right? So what I'm going to do is that I'm going to use these 2 formulas. So we said that 2 times tan inverse of x is equal to tan inverse of 2x, and as you can see, these formulas are pretty useful. 1 minus x squared for -1 less than x less than 1, and also we had basically tan inverse of x plus tan inverse of y. Tan inverse of y is equal to the tan inverse of basically x plus y, 1 minus x times y, and that is for y is less than 1. Now what you can do is that you can write 2 times tan inverse of 1/2. You can, based on this formula, call it number 1, for example. Based on number 1, you can write it as tan inverse of 2 times x. 2 times x would be 2 times 1/2. 2 times 1/2, 1 minus x squared, which is basically 1/2 squared. So, and that is equal to tan inverse of basically 2 times 1/2 is equal to 1. So that is equal to 1, and then 1/2 squared is equal to 1/4. 1 minus 1/4 is 1 minus 1/4. 1 minus 1/4 is equal to 4/4 minus 1/4, which is equal to 3/4. Now 1 over 3/4 is equal to 4/3. So that is tan inverse of 4/3, right? So which means that if I call this, for example, star, then star, the in star, the LHS is equal to basically this, which I can write as, instead of 2 tan inverse of 1/2, I'm going to write tan inverse of 4/3 plus the tan inverse of 1/7, and that is equal to, and then based on this formula, tan inverse of x plus tan inverse of y is equal to tan inverse of 4/3 plus 1/7 over 1 minus 4/3 times 1/7, and then basically what we need to do a couple of arrangements here. Basically 4/3 plus 1/7 is equal to 21. 7 times 4 is equal to 28, plus 3 is equal to 31 by 21. So 31 by 21, and 1 minus 4/3 times 1/7 is equal to 1 minus basically 4 by 21, which is equal to 21 by 21 minus 4 by 21, which is equal to 17 by 21. Now if I divide this one, 13 by 21, and divide it by 17 by 21, I will get 13/17. So that becomes basically, this is equal to 13/17. So this is equal to the tan inverse of 13/17, right? And that, by the way, is equal to the RHS, right? That is equal to the RHS, which means that the LHS is equal to RHS, and hence the identity is proved. Okay. Now the next question that we have is write the following functions in the simplest form. Now in the simplest form, that's a little bit of trouble you have to go through, but well, mathematics is always, of course, trouble. There is no mathematics without trouble. So number 5, we want to write in the simplest form. So you have basically, for example, the tan inverse of basically the square root of 1 plus x squared minus 1 over x, where x is not equal to 0. Okay, and you want to write this in the simplest form. Now you can see that, okay, so basically I was trying to explain this thing, and I got into a little bit of explanation, but then this is a little bit more tricky than I thought, or a little bit trickier than I thought. You see, when you want to write these in the simplest form, what that means is that you need to basically, for example, when you have the tan inverse function, then of course here you have to write this expression, this whole expression here, in some form of, for example, tan of some angle. And if you write that in terms of tan of some angle, then tan inverse of tan would give you the angle itself. So that's basically the whole process. Now, the way that you can do that is that usually you have to write x, for example. You usually say that let x be equal to, for example, some function like, for example, sine theta, for example, or cos theta, or tan theta, or and so on and so forth, depending on the situation. Now, the thing here is that basically the point here is that basically you have the square root function, and under the square root function you have 1 plus x squared. So in such situations, in order to basically get rid of the square root function and basically rewrite the expression, you usually have basically two identities that help in such situations, and that is, one of them is 1 plus tan squared x is equal to secant squared x, and 1 plus cot squared x, and 1 plus cot squared x is equal to cosecant squared x, right? So what that means is that I could either say, for example, let x be equal to, for example, something like tan x or tan theta, for example, or I could say let x be equal to, for example, cot of theta. If I say this one, what happens is that basically this whole expression becomes the square root of 1 plus x squared, which is tan squared theta, for example, minus 1 over, for example, x would be again tan of theta, and 1 plus tan squared theta would be equal to basically the square root of secant squared theta minus 1 over, for example, tan of theta, and the square root of secant squared theta would be basically secant theta minus 1 over tan theta. Okay, that is one possibility. The second possibility is that if I say that basically let x be equal to cot theta, then this whole expression becomes basically the square root of basically 1 plus cot squared theta minus 1 over basically cot theta, and 1 plus cot squared theta is equal to cosecant squared theta, so that would be equal to the square root of cosecant squared theta minus 1, and you divide that by cot theta, and the cosecant squared theta is equal to the square root of that becomes basically cosecant theta minus 1 over cot theta, right? Now I can tell you, well, this one might work. I don't really know if it wouldn't work, but I haven't tried it. I haven't actually tried this one. I know that this one works because I have actually done it. I mean, that meaning that I have solved the problem using this method. So I'm going to basically go with this variation, right? So I'm going to erase all of this, and I'm going to say that let x be equal to tan of theta, for example. Then theta would be equal to tan inverse of x, right? Now, if x is equal to tan of theta, then basically your expression becomes then tan inverse of the square root of 1 plus x squared minus 1 over x would be equal to the tan inverse of the square root of basically 1 plus tan squared theta, 1 plus tan squared theta, and that is equal to minus 1 over tan of theta and 1 plus tan squared theta is equal to secant squared theta, so that is equal to tan inverse of the square root of secant squared theta minus 1 over tan theta and then you can write this as the tan inverse of basically secant theta minus 1 over tan theta and then what you can do is that well, you can basically you have to make some arrangements here, meaning that secant theta minus 1 over tan theta, you can write it as secant theta over tan theta minus 1 over tan theta. Now you know that secant theta is basically 1 over cos theta, and tan theta is the same thing as sine theta by cos theta, and so cos theta and cos theta you can cancel out, so you will have that as basically 1 over sine theta, and basically 1 over tan theta is so now let me write these separately because this way we would get confused. So again, secant theta by tan theta, we said that it's equal to 1 over sine theta. Now 1 over tan theta is equal to 1 over sine theta by cos theta, which is equal to cos theta by sine theta, right? So I can write this as this part, I can write it as secant theta by tan theta, I can write it as 1 over sine theta, and 1 over tan theta, I can write it as cos theta by sine theta. And again, I can put these two together. I can write it as 1 minus cos theta over sine theta. So that's how I can rewrite this expression. So I can write it as tan inverse of 1 minus cos theta over sine theta. So that is basically that. Now, in order to basically rewrite these expressions, these two, you know that basically you have to use basically sine of 2x, and you need to use these two formulas, sine of 2x and cos of 2x. And you can see that let me write them over here, and then we will talk about the rest here. So if you write the sine of 2x is equal to 2 times sine x cos x, right? So that means that I can write the sine of basically x, which is 2x divided by 2. 2x divided by 2 is equal to 2 times sine of x divided by 2 times cos of x divided by 2, right? So that is basically one thing that I can use here. Moreover, I can write basically 1 minus you see 1 minus cos theta you see over here what we have is that cos of 2x is equal to 1 minus 2 times sine squared x. Also cos of 2x is equal to 2 times cos squared x minus 1. Okay. Now if I write basically in this formula 1 is positive, in this formula 1 is negative, right? Meaning that if I take this one to the other side of the equation, this becomes cos of 2x minus 1, and or I can write 1 minus cos of x, meaning that keeping 1 on this side of the equation, taking cos 2x to the other side, I will get basically 1 minus cos of 2x, and then I will take this term to the other side, which becomes 2 sine squared x, right? That I can do. And also now if I take this one to the other side of this equation, what I will get is that 1 plus cos 2x is equal to 2 times cos squared x. So you can see that I can use basically this one over here, 1 minus cos 2x, because I have subtraction here, but 1 plus cos 2x I cannot use it here because this is subtraction, this is addition, right? So I'm going to use this one, but then I need to make some changes to it. So the change that I'm going to make to this is that I'm going to divide this angle by 2. So 1 minus cos of 2x by 2, which is equal to x, is equal to 2 times sine squared. Again, dividing this angle by 2 gives me x divided by 2. And that is basically what I can use in this case, meaning that 1 minus cos x is going to be equal to 2 sine squared x divided by 2. So then I'm going to write this expression as the tan inverse of 1 minus cos x, 1 minus cos theta becomes 2 sine squared theta divided by 2, and sine theta would be 2 sine of theta divided by 2 cos of theta divided by 2. 2 sine theta divided by 2 cos of theta divided by 2. And so then, having all of that in mind, you have basically you can simplify this 2 with sine of theta divided by 2. Then you have sine theta divided by 2 divided by cos theta divided by 2, which is going to be tan of theta divided by 2. So you have tan inverse of theta divided by 2. And that is equal to theta divided by 2. Now theta is equal to tan inverse of x, so that is the same thing as 1/2 times tan inverse of x, and basically that is, I suppose, the simplest form that you can write. That is the simplest form that you can write that expression. Okay. So that was question number 5. Now question number 6 is we have another expression again that we need to write in the simplest form. Okay, so the next question that we have is question number 6. You want to write basically tan inverse of basically 1 over the square root of x squared minus 1 square root of minus 1 as in the simplest form, and here we have the absolute value of x is greater than 1. Okay, now to simplify this, of course you need to somehow write this in terms of tan of some angle, right? Now we said that basically tan 1 plus tan squared x is equal to secant squared x, and we said that 1 plus cot squared x is equal to cosecant squared x, which means that I can write this one as basically cosecant squared x minus 1 is equal to cot squared x, and I can write this one as secant squared x minus 1 is equal to tan squared x. So basically tan squared x is equal to 1 secant squared x minus 1, cot squared x is equal to cosecant squared x minus 1, right? So now if I let x be equal to, for example, cosecant of theta, then we have basically the tan inverse of 1 over the square root of x squared minus 1, that would be equal to tan inverse of basically 1 over square root of x squared would be cosecant squared of theta minus 1, and then basically we would have cosecant squared theta minus 1 would be cot squared theta, so that would be equal to tan inverse of basically 1 over square root of cot squared theta, and then basically I can write this as the tan inverse of 1 over basically cot theta, which is equal to tan inverse of basically 1 over cot theta is equal to tan theta, right? So tan theta, which is equal to theta, which is equal to, now here basically theta would be equal to cosecant inverse of x. So that is cosecant inverse of x. Now basically we said that secant inverse of x plus cosecant inverse of x, we previously said that in the formulas that we derived, we said that cosecant inverse of x plus secant inverse of x is equal to pi by 2 for all x's where the absolute value of x is greater than or equal to 1, right? So cosecant inverse of x plus secant inverse of x is equal to pi by 2 where the absolute value of x is greater than or equal to 1, which means that basically I can write cosecant inverse of x based on this as pi by 2 minus secant inverse of x. So if that is the case, then I can say that the cosecant inverse of x is equal to pi by 2 minus secant inverse of x. So cosecant inverse of x, I can write it as pi by 2 minus secant inverse of x. You can write them in these two ways. The next question that we have is question number 7. Question number 7, which is you want to write basically again in the simplest form. To write in the simplest form of, this is question number 7, tan inverse of the square root of basically 1 minus cos x over 1 plus cos x, right? And you have the tan inverse of this, where 0 is less than x less than pi. Now, in order to simplify this, now we need to use the formulas that we have for the cos of 2x and sine of 2x and those formulas. So if I think it was number 4. So you see over here, you need to be looking for something that, so for example, cos of 2x, and over here we have -1, so you would get 1 plus cos of 2x. That would be basically something that you could use here. And then 1 minus cos of x, you can write it as 1 minus cos of x. That's it. Let me see if I can find something here. No. 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 Okay, so I suppose no, again no. So that must be somewhere over here. So what we can do is that, of course, we know that cos of 2x, is equal to 2 cos squared x minus 1, which means that cos of x is equal to 2 times cos squared of x divided by 2 minus 1, which means that 1 plus cos x, taking 1 to the other side, 1 plus cos x is equal to 2 cos squared x divided by 2. Now I remember from a long time ago when I used to go to college that there was also something for 1 minus cos x, but I don't remember. I mean, I cannot exactly remember what that was. 2 sine squared, yes. So 1 plus cos x is equal to 2 cos squared x divided by 2. Now it so happens that 1 minus cos x is actually equal to 2 sine squared x by 2. 2 sine squared x by 2. And the reason for that is that basically you have cos of 2x is equal to 1 minus 2 times sine squared x, right? And of course, well, if I take this 1 to the other side, I'll have cos of 2x minus 1 is equal to negative 2 times sine squared x. And if I multiply both sides by a negative sign, 1 minus cos of 2x is equal to 2 times sine squared x. Divide the angles by 2, I get 1 minus cos of x is equal to 2 times sine squared x divided by 2. So 1 minus cos x is equal to basically 2 times sine squared x divided by 2, and 1 plus cos x is equal to 2 cos squared x divided by 2. We had to, back then we had to memorize all of these. So now let me actually make a note here, and then I will make a list out of these formulas so that we can, and then I will provide you with the formula so you can have them and use them later. Okay, so long story short, now 1 minus cos x is equal to 2 times sine squared x divided by 2. Okay, now what I need to do is that I can write this as tan inverse of basically the square root of 1 minus cos x. I can write it as basically 2 times sine squared x divided by 2 over 2 times cos squared x divided by 2, right? And that is, and 2 and 2 then you can cancel out. Now sine squared x divided by 2 over cos squared x divided by 2 is tan squared x divided by 2, so that is equal to tan inverse of the square root of tan squared x divided by 2, which gives you basically tan inverse of tan of x divided by 2, which is the same thing as x divided by 2, right? So that is basically the answer here. These are important, especially if you go to school, and these two basically you need to know these two in most of the exams. They are very useful identities in exams and such. So now question number 8 is again another question that we need to write in the simplest form. So you have question number 8 as you have tan inverse of cos x minus sin x. That's also a popular one. Cos x minus sin x over cos x plus sin x. And basically here negative pi divided by 4 is less than x less than 3 pi by 4. Negative pi divided by 4 is some angle down in the, this is negative pi divided by 4, and 3 pi by 4 of course is basically this angle over here. This is 3 pi by 4. Now, okay, so now there are no there is no identity that you can use in order to simplify this, but there is an interesting way to do this, and that is basically you can write this as the tan inverse of now if you divide both the numerator and the denominator by cos x, what you will get here is that you can write cos x by cos x minus sin x by sin x by cos x. Again, cos x by cos x plus sin x by cos x. Okay, and then what you can do is that now this is going to be equal to tan inverse of basically cos x by cos x equal to 1 minus sin x by cos x equal to tan x, and this is equal to 1 plus tan x again, right? Now, here what you need to do is that you need to write this as, so if I write this as tan of, basically you know that tan of pi by 4 is equal to 1, tan of 45 degrees. So I can write this as the tan inverse of tan of pi by 4 minus tan of x over tan of pi by 4 plus tan of x okay, and then this thing over here is equal to tan of pi by 4 minus x, because you know that tan of basically x plus y is equal to tan x plus tan y over 1 minus tan x tan y, right? Tan x tan y. That is tan of x plus y. So let me actually get this formula. Tan of x plus y is equal to tan x plus tan y, 1 minus tan x tan y. And also tan of x minus y is basically the same thing as tan x minus tan y over 1 plus tan x tan y. So that is that. Now if I substitute over here, if I substitute basically x as if I take x is equal to pi by 4 and y is equal to x, I'll have tan of basically over here pi by 4 minus x is equal to, based on the formula, I have tan of pi by 4 minus tan of x, and over here I have 1 plus tan of x, which is equal to tan of pi by 4, which is equal to 1. So I don't have to write it really, but it's tan of pi by 4 and tan of basically then I will have tan of x. Now since tan of pi by 4 is equal to 1, I can write this as tan of pi by 4 minus tan x over 1 plus tan x. So that is, and tan of pi by 4 of course is equal to 1 again. So I have 1 minus tan x over 1 plus tan x. That is tan of pi by 4 minus x. tan of pi by 4 minus x is equal to 1 minus tan x over 1 plus tan x. Or you can say basically, or you can say it is equal to, you can say it's also equal to tan of, for example, pi by 4 minus tan x over tan of pi by 4 plus tan x, for example. That you can say as well. That is also the same thing, tan of pi by 4 minus x, right? So this I can write as tan inverse of tan of pi by 4 minus x, and that is the same thing as pi by 4 minus x. So that is the simplest form of this question. Now there is a couple more questions that we will do in the next videos. I'll see you in the next video, and thank you.